Hey, my name is Ethan, and today I'm going to walk you through the Mixpeek search and discovery platform that supports multimodal file types. And so what we'll do first is we'll create a collection. And a collection is how files are organized in your Mixpeek account. So we'll call this collection test, and we'll upload a bunch of different file types. So these file types span images and videos. And we have a couple of JPEGs here. We've got an MP4, we've got a QuickTime file, and we have an HEIC file. And this is actually Apple's proprietary image type. Kind of a pain to process, but we did it. So we have all these different files that span images and videos. We can also add URLs, so files that are publicly accessible, as well as YouTube URLs. So we'll create the collection now, and what it's doing is it's running each of those files through the indexing pipeline. It's extracting embeddings, it's generating captions, it's pulling out objects, it's doing all of these different things using custom ML models in order to structure the data so that we can do intelligent search and discovery and analysis. And so this page will actually show the status of each of the files through the indexing pipeline. So we can see the videos, some of the videos are still processing, and it's actually chunking up the video into segments and processing each of those videos. So again, pulling out all of these data points like embeddings, captions, objects, etc., so that we can do some of these more intelligent queries and analysis. So we'll wait a second or two for these last two videos to finish up. This is a 10-second video, and this is actually a 1-minute video. Let's go back to the collections page and we'll do a search. Since those images are already finished, let's start with an image search. We can see here we have a picture of a damaged roof, and we have an AI generated caption that understood the contents of that image. So we'll do a search that will return that as the top result. So we'll just say damaged roof, and typos don't matter because again, we're understanding the semantics, the intention behind the user's query. So damaged roof here, we've got a picture of the damaged roof as well as this, again, AI generated caption, a view of a house that has been damaged by a roof. So this query is actually spanning both the image embedding and the caption. And it's combining both of these data structures to return the most relevant search result possible. And so we have the ability to search by text. Let's also search by image. So let's use this picture as a search query. And as we can see, we have it right here, but just for demonstration purposes, and just because we have only 6 images, we will use an image that we already have in our collection. So as expected, that image that's already in our collection is the top result because it is the most similar. So let's clear that out and let's go into our video modality. And in our video modality, the same kind of logic is possible. Let's search by text. So we'll say boy outside with dog. As expected, top result. So we have a list of the individual videos, and we have a color coordinated timestamp ranking of which timestamps are most relevant given the query. So we can see green here indicates the most relevant, followed by orange, yellow, and red being the lowest. Some of these results occurred is because we only have 4 videos in our entire collection, which is as expected. So let's try a reverse video search, just like we did with the image, and we'll use this drone footage here. So we'll do that search. Again, it's doing a reverse video search. So it's taking that video and using it as a query against our collection. And as expected, the video that resembles the one that we're using for our query is the top result. And again, we can view by segment to see the timestamp breakdown of which are the most results in which are the top results in our collection. And we have the start and end timestamps as well as the score. So this is the highest score, 0.88. We have some of these lower scores here, etc. And we have the ability to see the actual query that we're running. So we can copy this Python code into our code or our JavaScript, and we can look into our actual account to see the API key. So the goal of Mixpeek is to actually integrate this multimodal understanding capability into your application. Here's an example of a live use case that uses that reverse image search. So when we click one of these pictures, we actually are doing a reverse image search across an entire collection of images. So we can see we'll click this image and we'll find all of the similar images. We'll do another random, click this image, find all of the similar images. So it's doing that reverse image search using the Mixpeek image modality search capability. So again, that is the end-to-end breakdown of us indexing various file types into a Mixpeek collection and then doing a search and discovery query on that collection based off of the modality. So we have video and image, soon to be audio and text, and we'll have a number of other features that we'll expose that allows you to uncover some of these insights in your different file types, your videos, your images, your audio, and your text. If this excites you, reach out. Again, the website is mixpeek.com, and my name is Ethan. I'm the founder, and I'm very happy exploring use cases with you, and you can actually create an account for free on the website, get your API key, and start running. Thank you.